class. It was cancelled, and that's base of problems in the line connection. Do you have my voice and my sound? Okay, hello. Good afternoon. Are you hear my voice? Okay. Please let me know about my voice and the screen. Okay. First, I have a review about the last sessions that I stated before. Then I will start the new. In last session, I had stated about earthquake resistant structure techniques. Uh, I describe and explain about this isolation method, energy dissipations device, seismic damper, and keeping building up trust to reduce the earthquake energy and reduce destructions in the buildings. I had the introductions about resistant techniques, what's base isolation devices separated the building from ground by some rubber devices. And seismic damper as special devices that's introduced in building as absorb the energy produced by seismic wave and reduce the earthquake energy. We had three types of dampers: viscous dampers, friction dampers, yielding dampers. As before, I show you first these three types, how use these dampers, viscous dampers, friction dampers. I have talked before. And also I gave you some references to more study about these dampers and how to use these dampers and how reduce the energy. Another in last sessions I talked about I have talked about goals of earthquake resistant design. That's I stated that it is economically not feasible for ordinary building to be designed as absolute earthquake proof. However, the goals of EQRD, earthquake resistant design, are showed in this slides. And the earthquake, we have three levels of earthquake types: severity level earthquake, damageability level earthquake, and safety earthquake. Severity level earthquake, frequent, and we have in the frequent and minor earthquake, building should not be damaged and continue to remain in service. And in this level, expected 10 times during the life of buildings. And another level of earthquake type is the majority level earthquake. In this level, we have a occasional moderate earthquake, and it is not in this level. No structure damage is expected. Known structure should not lead to any loss of life, and expected once or twice during the life of building. And last level of earthquake types for earthquake resistant design is sea-level earthquake. In this level, uh, rare major earthquake, we have rare major earthquake, building should not collapse, and non-structural and structural damage should not lead to any loss of life. This we have here the short in the uh, properties of the earthquake types and showing these slides. For earthquake resistant design, uh, we talked about uh, symmetrical plan buildings uh, as plan, mass, and geometry plan building, elevations of buildings, building joint. We had talked before. If the or building uh, symmetrical in plan, the distance between center of mass that shows with COM and stiffness center of resistance are less compared of asymmetrical plans that's more strength and then can absorb the energy of earthquake and more strength and safe for building. Asymmetrical plane undergo large amount of torsion and hence extreme concerns are subjected to heavy forces. Symmetrical avoid asymmetrical buildings like the IU, U, and T-shaped buildings. In buildings, uh, we should use the symmetrical buildings to more strength as geometrical buildings with shapes uh, rectangular, uh, square, polygon, and circular. Some shapes look like this, more symmetrical and can give the building more strength. Also, we had some sample about geometrical symmetry in elevations, in glaciations, as stiffness symmetry and symmetrical stiffness builds, as shows in the slide. Also, I had talk about building foundations. We have problems may occur in the buildings. Problem, two problems we have according the building foundations. First, differential settlement in building foundations. Second one, liquefactions may occur in the building foundations and give the less strength and maybe give the collapse in the foundations and the structure of the buildings and uh, give the destruction. We have three solutions for building foundation problems. First, using high beam. A second solution is use raft foundation for building foundation, and third solution to solve building foundation problems base isolations. According that I described and it's in last sessions, and this slide shows differential settlement the occurring in the foundation building and then often give the floating overtraining in the building, as you can see in this slide. The resisting inertial force in the superstructure cases of field uplift and compression in the flat foundation at the differential in different in the as shown in this slide. Another problems in building foundation as shown in this slide. Three main prerequisites for liquefier action are shown in this slide. First, a layer of relatively low sand or silt we have in the dome of foundations. Second one, a water table high enough to submerge a layer of low soil. And third prerequisite for liquefaction is an intensity of ground shaking sufficient to increase the water pressure between soil particles to cause the soil mixture to liquefy. Can with the dynamic forces or earthquake forces can give this intensity of ground shaking to increase the water pressure between soil particles to cause the soil water mixture to liquefy, as shows this case. And some pairs the reactions uh, after liquefaction. Okay, this slide shows the solution for solve the foundations problems. Use isolated foundations as shown in this slide. Individual footing should be connected at times or a structure slab to prevent an relative horizontal movement occurring during earthquake shaking, as shows this first shape, and that shows the types of the use high beam and structure slab to prevent of any relative horizontal movement occurring during earthquake. Another solutions way use raft foundations as the raft has a common base and it equally and uniformly distribute the superstructure load to the subsoil as shows in this right shapes. In second shape, it spreads concentrated load onto a larger area and makes the structure tolerant of inner ground subsidence. It mobilizes the entire weight of the building that resists inertia induced overtraining movement. Another solution uses the base isolations between structure and ground to absorb energy and reduce the earthquake energy and more structure strength. As shows on of base isolations is slide. You can see the schematic shape of non-isolation building and give movement over training in the structure, and another one base isolation building can in stability more and than no distractions as shows in these shapes. In another slide shows some technique of making earthquake resistant structures. In the short answer, currently there are several design philosophies in earthquake energy, making use of experimental results, compare simulations and observations for past earthquake to offer the required performance for the seismic trick at the site of interest. There are five broad categories of a structure system which are taken into account that design earthquake resistance buildings. As shows in this slides, first bearing wall system using building frame system using movement, design frame system, dual system, cantilever, column system. We can use these techniques for making earthquake resistance structures as shows these slides. First, using bearing wall system, a structural wall located through the structure provides primary vertical support for the building's weight and that of its contents as well as the building lateral resistance. As shows in these shapes, in these pictures, building wall building are commonly used for residential construction, warehouses, and low-rise commercial buildings of concrete, masonry, and wood constructions. As shown for example in the pictures using wood, unlike standard masonry walls, which are solid interlocking mortar-less masonry blocks allow light movement over time. Ideal innovative application of steel reinforcement. This construction technique is also better at dispatch the energy of seismic wave than traditional machinery. Another way using bearing frame system for building construction of structural steel and concrete lateral resistance is provided either by diagonal steel members that extend between the beams and column to provide horizontal rigidity, or by concrete machinery or time-bearing shear walls that provide lateral resistance but do not carry the structure's weight. Do not, but do not carry the structural weight. Another using moment resistant frame used for both structure steel and reinforced concrete constructions. The horizontal and vertical column provide support for the structural weight and the strength and stiffness needed to resist lateral forces. Stiffness and strength are achieved throughout the through the use of rigid connection between the beams and columns that prevent these elements from rotating relative to one another. Moment resistant frame systems are popular because they do not require braced frame or structural walls, therefore permitting large open spaces and spaces with many on-off structures, window opening, those in the systematic shapes. Another way using dual system in the building. Dual is an economical alternative to movement resistant frames are commonly used for tall buildings. Dual system commonly used for tall buildings. Dual system structure feature combinations of moment resistant frames and concrete machinery or steel walls or steel braced frames. The moment resistant frame provides vertical support for the structural weight and a portion of the structural lateral resistance, while most of the lateral resistance is provided either by concrete machinery or masonry of steel walls or by steel braced frames, as shows in this uh, slides schematic shapes. You can see dual frames configurations and single frame configuration. As you can see in this schematic shape, you can see the displacement after earthquake in the single frame configuration more is increased and more than dual frame configuration as see in these schematic shapes. As you can see, and comparison and comprise between the dual frame configuration and single frame configuration. Also, I have talked about some earthquake building codes in Japan for earthquake and uh, based on the Japanese seismically active country and has some of the most rigorous earthquake building standard in the world. Some of the standards shows in this slide. You can search in internet and study these standards and codes for more knowledge and more information about standards and guidelines that describes and explain in the for the earthquake and seismic energy in the buildings. So we had some schematic shapes about some techniques and instrument using in the building to reduce earthquake energy and absorb and give less and reduce destruction in the buildings using base isolation, dampers, foam, turret, mass damper, liquid damper, some for most buildings, and using base of symmetrical elevation control. Some of these shapes as schematic shapes you had in as for example in this shape use base isolation bearings instruments in the tile and how use in the buildings in between a structure and grounds to absorb earthquake energy and more flexibility and reduce destruction in a structure and more stability buildings. Also here shows the comparison between the structure that use base isolation and another one without use base isolations and what happened in these two buildings as shown in this picture and schematics. Also talked about dampers and schematic shapes of dampers, oil dampers, viscose dampers, and how used in the buildings, building dampers. This is the pictures of using the dampers and bracing in the extra structure of buildings. You can use SC to these schematic shapes. This DMA standard guidelines for designing under earthquakes. This is a manual for design under earthquake for architects. So design under earthquake, you can use this standard and study. Or design under earthquake. This is one of the standard in the world. In USA also use these standards. Just a standard and guideline before I change. I have sent in the WhatsApp groups a study. Today I want talking about vibration and waves. Last time we I have talked about describe and explain about the types of waves and what is vibrations in the and properties of waves. Today also continue about the vibration, describe about vibration and waves. Now I am going to change my PowerPoint.
You are currently the only person in this conference.
I'm sorry, I have suddenly cut in line and again connected. Do you have my voice again? Please let me know. It's okay. 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 Vibration and waves. That's another fact. Okay, I am going to talk about vibration and waves. First, general definitions of vibration and wave. Vibration, we have definitions. Vibration, in a general sense, anything that switches back and forth, for to and fro, side to side, in and out, up and down, loud and soft, or up and down is vibrating. A vibration is wiggle in time. Another parameters is wave. As before, we have talked about the parameter types of wave, and wave. Now we uh, one about definitions about wave. A wiggle in both space and time is a wave. A wave extends from one place to another place. The source of all waves is something that is vibrating. Waves are propagations of vibrations throughout space. In definitions of vibrations, we have first example, vibrations of a candle. This shape shows the stick shapes of the vibrations of a pendulum. The two and vibratory motion is also called oscillatory motions or oscillations, vibration or oscillations, or oscillatory motion. As shows in geometric shape, we have a parameter of t period in the vibration force. What does the period or t depend upon? Also, we have in the vibrations parameter length of the pendulum shows with L, acceleration due to gravity, G, period does not depend upon the bulk mass or the amplitude of the sewing. This equation shows the equation T period. T is 2p square L per G with or period with these equations. This slide shows the vibrations of a spring, and that's the end of a spring is the mass. The mass vibrated with this spring, and shows the wave of harmonic motions, motion of amplitude of the wave as shows in these schematic shapes. When oscillations are the motion is called simple harmonic motion or SHM and can be described by a simple sine curve. This curve shows the wave motion and the amplitude of the motion of mass of a spring. We have some methods in the vibration as shows in this slide. We have wavelength, amplitude, or period.
You are currently the only person in this conference.